video I'm going to show you how I used a LED dimmer that's a radio frequency remote controlled unit to control the speed on a finishing motor setup that I built here. At some point I'm going to sell these stands, and I'm trying to decide if I want to sell the stands just by themselves with the motor mount already installed, or if I want to sell them with the motor set up and wiring already done. At this time I'm thinking I'll probably sell the stands by themselves, and that way people can install whatever type of motor they want to use because they're available in a lot of different configurations. You can get them anywhere from 2 RPMs all the way up to 1,000, and they all still running off of 12 volts. People might want to use the motors without speed control or with, and that would give people some options to pick their own motor setups. So this little remote unit, you can pick these up on eBay for just a few dollars. They're somewhat limited on the speed control. You don't have as much fine control over especially the low end speeds as you do with a dedicated pulse width modulator like I've shown on other videos. But what you gain is a lot less wiring and remote control capabilities without wires running across your work surface, so you get some convenience from that. So that might be a trade-off you're willing to make. These little remote units can be found on eBay. You can find them on Amazon also. The prices range anywhere from around $2 up to about $5 or so. They're relatively inexpensive. I'm just going to be using a few basic tools, some wire strippers, a multimeter, and I'm just going to set that multimeter at 20 volts DC, a 12 volt power supply that's about 1.2 amps. These motors run off a half an amp, so 1.2 is plenty. I'm also going to use some heat shrink tubing, a heat gun, solder, and a soldering iron, and of course the remote control unit itself. It's very tiny. It doesn't take up a whole lot of space. The remote's very small too, and I chose this particular dimmer unit because it has speed selections that go 100, half, and 25%. So those speeds aren't exactly right, but it will give you a slow, medium, and fast speed. The first thing I'm going to do is cut the plug off of this power supply unit. Some people call these wall warts. This is a switching power supply. It's not a transformer, and it provides a little over an amp and 12 volts. And when I check this with the meter, it will probably read higher than 12 volts. Most of them do, but that's with no load on it. Once you put a load on it, it'll usually drop that voltage a little bit. After I cut the plug off, I'm going to separate the two wires that went to the plug, and I'm going to strip those back. I'm going to check the wires to figure out which one is positive and which one's negative. And they usually mark the wires, I've noticed. Usually there's a white dashed line on the wire that is the positive side, and the negative doesn't have the white dashes running down the line. I wouldn't trust that. I'd go ahead and check it with a multimeter, because if you get this little remote unit hooked up backwards on the power supply side, it can cause them to melt and even possibly catch fire. They're not supposed to be hooked up the wrong way on that end. On the output side, it doesn't matter which end you hook to positive or negative on your motor. The only difference that makes is for which direction you want that motor to turn. The way I'm going to check for the positive and negative side is to hook my multimeter up to it. If you hook it up one way and you get a positive voltage, you know that your red lead is your positive side of that power supply. If you hook it up backwards, the red lead will go to your negative and you'll get a negative reading. So now we know which lead is positive and which lead is negative on the power supply side. I'm going to go ahead and do a little work here and bend the leads that are coming off of this remote control receiver. I'm going to bend those around. That way, when I get ready to tie all these wires together, I'm going to be able to cover it all in some heat shrink tubing and package it up to kind of release some of the strain on the ends where they've been soldered. So I'm just going to find some heat shrink tubing that is fairly large. And I'm also going to be using some smaller diameter heat shrink tubing to insulate the wires from each other inside of this bundle. And I'm going to cut those to the length that I need. I'm going to cut off a length of the power supply cable itself, and I'm going to use that as a pigtail to run from the output side of the receiver unit to the motor. Now I'm just going to separate the wiring that comes from the power supply and strip those ends back so I can hook that up to the input side of the receiver unit. Before I solder those connections together, I'm going to have to go ahead and put my heat shrink tubing on. Don't forget, it's absolutely critical that you get the positive lead from the power supply hooked up to the positive input power voltage side of the receiver, and the negative to the negative of those two. If you don't, you're going to fry your board, and that's the best case scenario. You might catch something on fire. Hook these wires up correctly and you won't regret it. Make sure you use flex core wire that is made for electronics hookups, not plumbing, because plumbing solder has acid in it. You don't want that on your electronics. I'm just going to solder these wires that I've twisted together, and I'm going to do the positive and negative side, and then I'm going to finish up by sliding the heat shrink tubing up over those connections and heating that heat shrink tubing up so I can shrink it down. That way I've got both of those wiring connections insulated from each other. Now I'm going to slide the larger diameter heat shrink tubing over everything, slide it down to the power cable. I'm going to go ahead and hook up the motor side connections now, and I'm going to do that a little different because I want my motor to run backwards from normal. So what I'm going to do is I'm going to take the dash side that should go on the positive side normally, that's coming off of the power adapter, the little white dashes. I'm going to hook that up to the negative output side. That way I know to hook that end up to the positive side of my motor. That will make it run clockwise instead of counterclockwise. That's the direction I want it to spin. I've already checked this out. I need to hook up my positive motor side to the negative side of the output from the receiver unit for the remote control. That will make it spin the direction I want it to turn. If you wanted to, you could hook you up a double pull, double throw switch in line here. That way you could reverse the motor if you wanted to. I'm not going to do that. I don't really think it's necessary because I'm using a slip clutch chuck. If I need to back it up, I can do it manually. At this point, I'm ready to bundle these wires together and put the larger diameter heat shrink over the top of everything to tie everything together. That way the solder joints have a little bit of a protective area to keep the wires from being pulled apart too much. It'll kind of cinch everything down into a neat little package. Now that all the connections on the receiver board are made, I'll need to go ahead and tie the wiring from the receiver board output to the motor itself. And once again, I'll separate these wires and I will hook up the side with the white dashes, which I hooked up to the negative output from the board. I'm going to hook that up to the positive side of the motor. And the side without the white dashes, I'm going to hook up to the negative side. And that will, as I said before, cause my motor to turn clockwise instead of counterclockwise, which is what I want it to do for this particular application. I'm going to install my heat shrink tubing ahead of time, and then I'm going to make my connections by twisting the wires through the holes that are on the motor inputs. I'm going to twist those wires and then I'm going to solder them to the motor inputs. And I'm going to try to do the soldering fairly quickly, that way I don't damage any of the insulators for the motor itself. It looks like it probably has some sort of just a plastic insulator on the cap. And now I'm just going to slide my heat shrink tubing up into place. And the reason I'm using this here is I don't want anything to be able to short out across the post on the motor itself. So I just wanted to add a little bit of insulation there with the heat shrink. So I'm going to slide those in place, heat them up, and shrink them down. Now, a smart person would have checked all this and made sure everything was running right before they buttoned everything up, but I never claimed to be that smart, so I'm going to try it out and let's see how it works. Everything seems to be working, so let's try to lay down some thread. Now, I'm not claiming that this is the same thing as a rod wrapping lathe. It's not meant to be. It's just meant to be a way mostly to do finish work with epoxy, where you can spin the rod at a fairly fast speed. But you can use it also for laying down some thread if you need to lay down a long wrap for some reason. This will really speed that process up if you're using a hand wrapper. I'm just moving my thread carriage along my alignment rod on these rod making jigs that I sell. I'm just sliding it as I need to in order to keep my angle correct so I don't get any thread overlap or any spacing between my threads. I was just playing around with the buttons on this. Now there's 100%, 50%, and 25% quick buttons you can push, and the 100% is pretty close to a full speed on the motor. The 50% is not halfway, it's a little more than that, and the 25% is not a quarter of the speed. In fact, I don't think this thing will even turn a quarter of the speed without stalling. It might get close to it. It seems like about where the fine line is about 85-ish RPMs on this 200 RPM motor. So the control of it's not as fine as a purpose-built pulse width modulator that I've used in the past, but the convenience of it is through the roof. I mean, it's awesome not to have cords all over the place trying to run this remote unit. Before, my previous remotes were not wireless. They were remote units in boxes, and I'd have to move them up and down the rod as I needed to. The problem with that is you've got cords laying everywhere, and you have to store those cords when you get ready to put everything up. I just really like the convenience of this remote unit. Now, I don't know how long these remote receivers and senders will last. I've heard that it's a common frequency and that you have to periodically resync them by holding down the plus and minus buttons that are on the lower section of the remote and near the mode buttons. And you don't need those modes for rod wrapping. You only use really the dimming effects on the top. The modes do weird things like make the motor run for a second and stop, and run for a second and stop. There's a lot of different modes. I played around with it. They're not anything useful as far as I can tell. So, but the plus and minus buttons down by the mode buttons, if you hold both of those down simultaneously, you can resync the remote to the sender unit if you run into a problem where it's lost connection for some reason. I haven't run across that yet, and there might not be enough remote things in my area. I live kind of out in the middle of nowhere. We live in kind of a rural community, so there might not be as much interference where I live as somebody in, say, an apartment in New York City would have. You know, that could be part of the reason why they lose sync sometimes, but I have not experienced that myself. I've just read in the reviews that that is one of the things you have to do with these periodically. The bright plus and minus buttons will speed up and slow down the motor also. I find that if you hit the 25% button, you can get away with 2 bright minus pushes to slow it down just a little bit more. On the third one, the motor stalls. And if you do 2 pushes of the bright minus, it gets down to probably around 80 RPM, and it runs fine like that. One more push and it stalls the motor almost every time. That's just something to keep in mind. You don't have the low end that you would get with a pulse width modulator that is built for motors. I thought y'all might be interested in that, and I will hopefully have some stands ready to be sold here shortly, hopefully within the next couple weeks. And when I do have those ready, I'll be sure to put a video out about that. I plan on making the stands with the motor mounts already installed, and you can use any of the 37 millimeter modular type motors that will fit those motor mounts with this stand, and have a fully adjustable height stand to go with your motor that you want to use for either doing finishing work or doing rod drying, or even laying down some thread if you want to do that with a hand wrapper. That's all I've got for now. I'll talk to you guys later.